Question 1a, part 1, we need to find the number of elements in A. So A is the multiples of 3, and they are greater than 1 but less than 20. So I know that 3 times 6 is 18, so we've got 6 multiples of 3 that's going to be greater than 1 or less than 20, and if we went 3 times 7, we're actually going to go over to 21. So the answer to number 1a, part 1 is 6, and we can see that clearly if we just write them out. We're going to have 3, 6, 9, 12, 15, 18. The first 6 multiples of 3. Now, for part 2, we need to find the number of elements in A intersection B. So B is the multiples of 4. So we need something that's a multiple of 3 and also a multiple of 4. So the lowest common multiple of 3 and 4 is 12. So any multiple of 12 is going to work. And as you can see, when we wrote out the elements of A, we've got 12 here, but we don't have a 24 or anything. So we're going to just have that one element. So for A part 2, the answer is just going to be 1. Question 1b, on the Venn diagram, we need to draw the sets P, Q, and R such that P is a subset of Q and Q intersection R is equal to the empty set. So I'm going to start with this one here, because as their intersection is equal to the empty set, Q and R are not going to overlap at all. So I could draw something like that for Q and then R there, so they don't overlap. Now we'll look at this part. P is a subset of Q. So P is going to be contained entirely within Q. So I could draw P as something like that. Okay, so that is 1b. For 1c, we need to use set notation to describe the shaded areas shown in these Venn diagrams here. So we'll start with this one. So we've got everything shaded that is not S and it's not T. So if we think of just those two circles that are in white there, if we had those shaded and nothing else, well, that would be S union T. So we can write our part then is, well, it's everything except S union T. So we'd write that as the complement of S union T. So another way to think about that one is if we shade everything not in S, so I'll do that in red, everything not in S, just sort of roughly there. So that's all the part in grey and also anything that's in T. So that's everything not in S. Now if I use blue to shade everything not in T, so not in T is all through here, etc. So the part we want then is where those red and blue lines overlap. So that's the intersection then of everything not in S and not in T. So we could also write the answer to that one as the intersection of complement of S and complement of T. So now we'll look at this part here. And there's a couple of ways to think about it. One is to think, well, where does X intersect Y? So that was this part, it's that shaded part. And then where does X intersect Z? So that would be through here. And we want the union then of those two parts. So what we've got is we're going to have X intersect Y union X intersect Z. So that is one way to write the answer. And now we'll look at one more way. So I'll take this part off. If we think of Y union Z, so it'd be all of Y, shade in the yellow, all of Z. And now if I shade X with these red lines, well, the part we want then is where those red lines and the yellow shaded part intersect. That's the part that we're after. So that is going to be X intersect Y union Z. Okay, so that's another way you could write the answer. Okay, and that is question 1C.